Here's some more problems from section 10.1. This is number 31. And again, we want to find the arc length of t between 0 and 3, inclusive. And then this is our x, and this is our y. So again, for our formula, we're going to have to find dx dt and dy dt. A little error there. That should be dy dt, excuse me. All right, so we take the derivative. And again, these are off my notes. I got some whiteout so if you can read this. So this is the x. So when I take the derivative, it's going to be 3 halves times, and I brought the 1/3 out, so it's 1/3. There's the 3 halves from the power rule. And I subtract 1 1/2, and I have to take the derivative of the inside, which is 2. So there's my derivative. And the 3 over 3 is 1, so I just have, and I had times 2, so this all becomes just this simple. 2t plus 3 to the 1/2 for the square root of that. Okay? So that's the dx dt. Right? And then dy dt, these were kind of set up so they would work out nicely. So it was very kind of the book. Otherwise, you could use your calculator if they're real difficult. But usually they're set up so the algebra can be handled. Okay, so this is going to be, this is y, t plus t squared over 2. So if I take the derivative, that's just going to be 1. And that's just going to be 2t over 2, which is just t. So we put this in our formula. The integral from 0 to 3 of the square root of dx dt squared plus dy dt squared. Okay. Hope you can see that. Now this worked out nicely because I've got the square root of something to the 1/2, so that just becomes 2 times 1/2 is 1, so that's just 2t plus 3. And then this I just have to multiply out. So that's going to be 1 plus 2t plus t squared. Then we can combine like terms, and this is what we get. T squared plus 4t plus 4. Well, what do you think? This actually is a perfect square. But how nice does it get? All right, so I can factor this as t plus 2 squared. So the square root of t plus 2 squared is just t plus 2. All right, and then we just take the antiderivative of that, so that's just going to be t squared over 2 plus 2t. And then we have to evaluate it from 0 to 3. Well, the zeros go away, so we just evaluate this at 3. So we get 9 over 2 plus 2 times 3 is 6. So 9 halves plus 12 halves is 21 halves. 6 is 12 halves. So these are all pretty well designed, so they work out for you nicely as far as algebra is concerned. Okay? And number 33. This was x 1/3 t cubed. This was y 1/2 t squared. We want to go from 0 to 1. So those are going to be my limits of integration for my t values. I just take the derivative. The derivative of 1/3 t cubed is just t squared. 3 times t squared over 3, which is just t squared. And the same thing, 1/2 t squared. The derivative of that is just t. So we put these into our formula. So this is going to be dx dt squared plus dy dt squared. And that's going to end up being t to the 4th plus t squared dt. Okay, now how can we deal with this? Well, we can get there's a perfect square factor. We can factor a t squared out here. And that's going to leave me just with t squared plus 1. And the square root of t squared is just t, so I can bring that out. And then I can write this as a power, so I would have the square root of t is out front. Okay, and then I can write this as t plus 1, or the square root of t plus 1 squared times t. And I put the t over here. So this is what I had, and I wanted to get this in the form of u to the n du. I didn't want to do a whole u substitution. So I know that the derivative of t squared plus 1 is going to be 2t. So it's really kind of like a u substitution. You're going to let u equal t squared plus 1. Hope you can see that. So du would be the derivative of that, which should be 2t dt. So this is kind of like a u substitution. So what I did was I needed a 2 here to make this the du. So I put a 2 here. So I had to put a 1/2 in front. Okay, so that wasn't there. And so these red elements were not here. So when I wrote this down, that would have just been the square root of t squared plus 1 times t. Now I didn't have a lot of room. You can see I'm running out of room on my page here, and I got stingy, and I didn't want to use another page because I was pretty much almost done with this. So I kind of did combine steps. Okay, so I hope that's not an issue for you. So basically, just don't think about seeing these two things here. And this is what you had. You had the square root of t squared is t, and then this would be just t squared plus 1 to the 1/2 power. And that way I can apply the power rule, u to the n du. So the derivative of u to the n du, the derivative of the du would be 2t. I had the t by doing this little handy little square root. Okay, so I just need a 2 there. So if I put a 2 here, I have to put a 1/2 in front, and 2 over 2 is 1, so that balances it out. So that's kind of like doctoring it up, which is the way I learned it when I was in college. We didn't use this nice u substitution method. We just had to kind of say, well, I have u to the n du, so what I need over here, I need a 2t. I have a t, so I just need a 2. So I put a 1/2 there. All right, so we're all ready to go. So the antiderivative of this is going to be 1/2, and then this is all set up as u to the n du. So it'd be t squared plus 1 to the 3/2 times 2/3. And 2 over 2 is 1, so this is just going to be 1/3 t plus 1 to the 3/2 from 0 to 1. Well, if I put 1 in here, I have just 1 plus 1 is 2 to the 3/2. If I put 0 in here, I just have 0 plus 1 or 1 to the 3/2, which is just 1. And then I can simplify this. Remember, there's lots of ways to do this. We usually try to root first but power second, but that's not going to work so well. So here I'll power first and root second. 2 cubed is 8, so I've got the square root of 8 minus 1. And this is all over 3. And then I can take the 4 times 2 is 8, so I can take that to be, I can take out a 4. The square root of 4 is 2, so I have 2 times the square root of 2 minus 1 over 3. So that's your final answer. Okay? So I hope that makes sense. Like I said, I'll probably, maybe this summer, have time to redo these. And I would probably show more of those steps. Okay, so I hope that helps and answer any questions you have on this homework. And again, always, if there's any questions, just check with me in class.